The number system consists of the real numbers. So we have real and imaginary numbers. We do imaginary numbers later in the year, but real numbers are everything that we know, every kind of number that we know so far. So they can be fractions, decimals that stop, decimals that repeat. So the most specific type of real number is a natural number, and natural numbers are counting numbers. So we count 1, 2, 3, 4, 5, etc. Whole numbers include the natural numbers and 0. So whole numbers are called whole because they don't have any fractions or decimals with them. Integer is a positive or negative whole number. A rational number is a number that you can express as a fraction. So you can think of fractions such as, or decimals such as negative 1.07. This would be negative 1 and 7/10. So you could write it as a fraction. This would be 3/10. So you can write it as a fraction. And irrational numbers are the opposite of rational. So you cannot write these numbers as fractions. They are decimals that do not repeat, and they go on forever. So here are a few examples. So in this Venn diagram, it means that every natural number is a whole number. Every whole number is an integer. Every integer is a rational number. So you could say that every natural number is a rational number. But you can't say that every rational number is a natural number. So think of it, I like to think of it as living in Michigan. If we live in Michigan, we live in the U.S. If we live in the U.S., we live on Earth. Okay? So if you live in the Michigan, you live in the U.S., but if you live in the U.S., you don't necessarily live in Michigan. If in the U.S., you could live in Ohio, you could live in Florida, but you're not living in Michigan. If you live in the U.S., you live on Earth. But if you live on Earth, you don't necessarily live in the U.S. So that's kind of how the Venn diagram works. And you would have Mars off to the side. So Mars would kind of be like the irrational numbers. So you can't be on Earth and Mars at the same time. So just like your number can't be rational and irrational at the same time. So example 1, list all the number sets. So you want to start with the most specific number set. So this is not a natural number. It's not a whole number. It's not an integer because it has a decimal with it. It's a rational number. So if it's a rational number, it's automatically a real number as well. Okay, square root of 26. If you put that in your calculator, it's a decimal that goes on forever. So it's an irrational number. So it's also a real number. And then negative 4. Negative 4 is an integer. It's a positive or negative whole number. So if it's an integer, it's automatically a rational number and a real number. Example 2, which number set best describes each variable? So the age of a U.S. president. So when we're talking about ages, we usually say, I am 20 years old or I am 15 years old. So in that case, we're talking about natural numbers. It wouldn't be a whole number because presidents have to be at least 35. So I'm going to write the natural numbers. Area of a circle. So area of a circle is pi r squared. Now pi is an irrational number. Pi has a decimal that goes on forever without a pattern. So this area would be an irrational number. And then shoe size, you can have shoe sizes that are 7, 7.5. So because we added a fraction to it, it's going to be rational numbers. Okay, second part, additive, inverse, opposite. Additive inverse is another way to say the opposite. So the opposite of 7 is negative 7. Because when you add those two numbers, you get 0. Okay, so they're additive inverse. That is the same thing as opposite. The additive inverse of 2/3 is going to be negative 2/3. Now, multiplicative inverses are two numbers that when you multiply, you get 1. They were also called reciprocals. So these two are synonyms, and these two are synonyms. So The reciprocal of 2 would be 1/2, because if you write it as 1/2, you get 1/2. The reciprocal of 2/3 is 3/2, because if you write it as 1 divided by 2/3, remember when you have a fraction, you flip and multiply, so this becomes 3/2, 3/2. These two would cancel out, and you'd end with 3/2. So the reciprocal of 2/3 is 3/2. So we're going to find the opposite and reciprocal of each of these. So opposites I'm going to do first. So opposite of negative, or 1.2 would be negative 1.2. The opposite of negative 3.3 is 3.3. The opposite of negative 4/3 is 4/3. Now I'm going to do the reciprocal of each of these numbers. So when you have a decimal, I'm going to write the decimal as a fraction. So this is 1 2/10, which turns into 1 1/5 if I reduce it. This is a mixed number. A mixed number is when you mix a whole number with a fraction. So it's mixed number. So I'm going to change this to an improper fraction. So to change it to an improper fraction, I multiply 1 times 5, and I get 5, and then I add 1. So improper fraction would be 6/5. So I've done all this work so far, and I've yet to find the reciprocal. But the reciprocal is when you flip the fraction over, so it's going to be 5/6. So the reciprocal of 1.2 is 5/6. And you can check this by multiplying 1.2 times 5/6, and you'll get 1. So I'm going to do this similar with the next one. So I take 3.3, which is 3 3/10. 3 3/10 does not reduce, but this is a mixed number. So I'm going to write this as an improper fraction. So it's going to be 33/10. And then now to find the reciprocal, I flip it over. So it's going to be 10/33. And the reciprocal of 4/3, this one's easier, is just 3/4. Another important concept about number is absolute value. So the absolute value is the distance a number is from 0 on the number line. So since we're talking about distance, it's always positive. So it's always positive. Or a better way to say it is actually it's always non-negative, because the distance could be 0. And 0 is not a positive number. So this diagram right here is showing absolute value. So if you start at 0, the absolute value, we use these symbols, of 3 is 3, because 3 is 3 units away. The absolute value of -3 is 3. And then right here, the absolute value of 1 is +1. The absolute value of -2 is 2. So absolute value kind of works with parentheses too. So you want to do what's inside the absolute value first for order of operations. So letter A, evaluate each. You want to do what's inside here. So 3 minus 5 is -2. So the absolute value of -2, so if here's 0 on the number line, here's -2. -2 is 2 units away, so the answer is 2. Letter B, you want to do what's inside the absolute value first. So -2 plus 5 is 3. The absolute value of 3 is 3. So 3/6 is 1/2. And then letter C, I want to do each of these first. The absolute value of -3 is 3. The absolute value of -2 is 2. So 3 plus 2 is 5.